Today's video could be the least cinematic thing you ever watch in your entire life, dude, but no promises. Because we're just going to spend it down here in the bowels of the GWM Canon Alpha plug-in hybrid. Two objectives, really. One, to see how it actually works and where the bits are and what they do and how they interact, blah, blah, blah. And two, let us look inside, under the skirt, at the spectre of Chinese manufacturing, which I know, if the comments in recent videos is anything to go by, is a point of contention for at least some of you. So the reason I want to do this, and I have spent a good half a day under here now with a torch looking at this and that, the reason I want to do that instead of, I don't know, an off-road test like a lot of reviewers is because I already know how this vehicle's going to go off-road. Answer: better than the tyres it comes with. I mean, the tyres are its great limitation. It's got these Gitty X-Ross, whatever, highway terrain tyres, and in an off-road context, they will be shit. Preposterously shit. So there's really no point in testing that. And I note in GWM's recent publicity stunt where they threw one of these up this legendary, in inverted commas, beer o'clock hill, the only modification they did was to fit a decent set of off-road tyres. So if you do an off-road test on this vehicle, like you pick it up, you do an evaluation, you take it off-road, you're really just testing the tyres. And I already know the answer to, are they any good off-road? No, they're not. So let's talk about all of the stuff that is far more important to you, the potential owner-operator of a vehicle like this. Where are the bits and how well did they stick them in there? Let's go. I've had a very careful look around now, and happily enough, nothing about this vehicle from the undercarriage screams Dodgy Brothers, which is quite uplifting. The chassis is very beefy. It's about 90 mil across and about 150 tall, and it looks like it's made of, let's call it 3.5 mil section, and it's your typical chassis construction where two C-shaped channels are put together like that and then seam welded along their length. So the welds themselves, I've had a good look at dozens upon dozens of welds, and the welding control is really good. It's robotic MIG by the look of things, so it seems more consistent from a start-stop sort of point of view, and where the welds start over here and where they start in corresponding components on the other side. It's more consistent than a human would be at things of that nature. So once the process control is in place and once you've got someone monitoring that nothing is evolving in the time domain on the production line, then you basically get a good result. The chassis is also quite inboard from the edge of the vehicle. It looks like it's about 200 in from the edge of the vehicle. There's some pretty beefy standoffs from the body across to the side steps, so that's kind of nice. Coil sprung rear end, which will be good for on-road handling. And basically, the only nitpicking bastardry that I can come up with on a fundamental level about where things are and how well protected they are is there's a bunch of plumbing here connected to a widget, and I haven't gotten to the bottom of exactly what the widget is, but it's something to do with fuel or something to do with cooling the battery. And it's basically right smack bang here in the middle of the wheelbase, which means it is potentially a little vulnerable to a breakover angle compromise, right? So like a ramp angle compromise. And that means, you know, if we've got a big rock and it's in a hump, you could scrape some of this, and they could have done a better job, I think, with a different widget or mounted differently to get this low hanging plumbing out of the way. But even there, I have to give them some credit because this plumbing is higher up, like less vulnerable than the leading edge of the bottom of the fuel tank, and it's also substantially higher than this trailing edge of the lowest point of the transfer case. But aside from that, everything that matters seems to be remarkably well protected. There's some decent sort of scuff protection on the fuel tank, decent metallic plates up the pointy end too under the engine and transmission. So they haven't gone with just plastic bash plates. They're proper pressed steel sheet metal bash plates. They're probably not off-road racing bash plates, but if you spend 65, 70,000 bucks on a car, how much abuse are you really going to subject it to? So anyway, I'd give them a big tick on fundamentals, but maybe they could look a bit harder at that if you, because I'd be worried about that if I was going to do any rock hopping kind of stuff. The inherent complexity of this vehicle is very apparent when you get under here and have a look, because there is so much cabling and plumbing running from one end, this being the blunt end, to the pointy end. The battery obviously down here where the spare wheel would be in the majority of utes, and it needs a cooling system, the heat exchanger right up the pointy end. So you need delivery and return lines for the cooling system. You need high voltage cabling, which comes out of both sides of this battery, and it broadly heads this way. There's a big electric motor, 120 kilowatts, just under here inside the transmission. So obviously you need to take electricity all the way from there to there via a power control system. And there are actually two power control systems. There's a PCS here, which is basically in line with the charging port just forward of the rear wheel. So there's all kinds of plumbing and wiring going into this, plenty of orange high voltage connections into this box, which is just on top of the exhaust system, and there's a dirty big heat shield between the two of them, understandably. And then there's another PCS of sorts under the bonnet, right? And it's obviously there to do whatever electrical voodoo needs to be done to get electricity in to motivate the electric motor inside the transmission. But this is a very complex vehicle, and one of the upshots of that complexity is going to be modification. We're standing under the tray at present, and there is a lot of shit under here and a lot of shit that you don't want to damage. I wouldn't want to damage the PCS. I would not want to drill a hole randomly in the tray and hit a high voltage cable. That might be memorable. I also would not want to nick a cooling line that takes cooling oil from the battery all the way to the heat exchanger or back. And I wouldn't want to nick the battery box either, because the battery box is actually very tall and must sit just underneath the sheet metal floor of the tray. This means measure thrice and drill once, dude, unless you want to be enveloped in a blinding flash of light, or give the whole car a thermal runaway as you drive down the road in 100 k's or something. And also for the aftermarket industry, it means that a tray is going to be a particular challenge, like pulling the tub off and replacing it with a tray and maintaining all of this functionality without engineering in some sort of unforeseen compromise is going to be pretty difficult. Time to talk about the elephant in the room, which would be the battery and its location, because I suspect this will be a hotly debated topic. This is the tow bar, and that's the rear differential housing and the battery box, and you can only see one of the two battery boxes. There's actually another one on top and slightly offset forward, but from where you're looking you can really only see this bottom one. It's actually twice as big as this height would suggest. So it's obviously right up the back here, and that means it's intrinsically vulnerable to impact damage from the rear, which would be one of the most common kinds of car crashes that we have in our society, because, you know, texting dickheads are everywhere, aren't they? Obviously the tow bar is here, and that might help a bit, I guess, but what you can't see from where you're looking is there's another very heavy cross member just up here. It's only 20 millimeters, 30 millimeters higher than the top of the tow bar, right? And it's kind of heavily engineered. Like, there would be a dude in China somewhere with a degree in engineering, and his whole job would be that beam and the FEA of that beam and making it so that it could effectively transmit as much impact load as possible into this chassis rail here and its counterpart over there on the other side. And obviously that is a mitigation up to a point. For a kind of minor impact, minor, mild, whatever you want to call it, that's pretty good protection for the battery box from that kind of crash. And there might be other countermeasures as well, because there's about, I'm going to say, 80 or 100 millimeters of clearance between the forward edge of the battery box and the cross member just here. And that means that if they did some mad engineering design with these aluminium brackets that hold the battery modules in place, they could shear off and allow the battery box to move forward if we went to the next level of kind of impact mitigation. So I'd suggest that they've done what they could. And I was forced to think, the latent engineer in me was forced to think, well, how else would you do it? Because there's really no other space here. You need an exhaust system, which is on the right-hand side, and you need a fuel tank, which is kind of on the left-hand side. The only other option that I think is viable for the location of a battery in a vehicle such as this is just behind the bulkhead at the leading edge of the tray. You could have a different shaped battery module that was basically a slimline thing that ran the width of the tray at the front, and it would need its own enclosure, obviously, so that it didn't get damaged by loads that you put in there. You'd lose a little bit of load space. You'd be able to have a spare under here, and the battery would be less vulnerable to rear end impact. On the plus side, of course, you'd have to say that the passenger compartment is 2 meters that way. And if there is a thermal runaway event with the battery, that's a long way from the passenger compartment. And if you compare that, for example, with the Jeep Wrangler 4xe, in which the ceiling of the battery compartment is the floor of the passenger compartment, they're the same piece of metal. There's no gap in between them, or it's not 2 layers or anything like that. It's the one piece of metal doing 2 jobs. It's the battery enclosure, and your tootsies are on it just underneath the freaking carpet when you sit there inside that vehicle. So if it has a thermal runaway, it vents into the cabin, which is the ultimate design deficiency when you think about it. Whereas with this car, if there is a thermal runaway, it's happening a long way from the passenger compartment. So good news, bad news there. I know this is a steel bash plate, and it actually has about 16, 20 millimeters, like 5/8 of an inch worth of foam under here, as well as a sort of protective barrier. So obviously they're not relying on convection in any way to keep the battery cool. It's got a liquid cooling system, of which I think these 2 are the ports, and it pumps coolant all the way to the pointy end, as I said earlier. Now, that means, because it's got to go via the PCS, which also needs cooling, because it generates heat, that means there must be 13 metres of cooling plumbing for the battery on this vehicle, which is a lot of plumbing to maintain as the vehicle ages. Now, I don't know how well they've designed that. It's probably quite robust. But I guess, like a lot of these new things, only time will tell. I think that's basically covered off everything I needed to say about the battery, except to say that it's the nickel manganese cobalt chemistry, which is susceptible to thermal runaway at a lower temperature threshold than the iron phosphate chemistry that the BYD Shark 6 has as well. Sorry, I must be getting old, having a senior moment there, but we might be able to edit that out. Let's just talk momentarily about the exhaust system. It's got plenty of heat shielding, and the heat shielding is professional, It's nicely formed and really well anchored in place at all of these different points. They basically have a heat shield there's a specific heat shield for the rear part of the PCS, and then there's a heat shield running above the muffler and catalytic converter, basically the full length of the passenger compartment floor, and that would be on the driver's side. Okay, so that's great. They've done a very professional job with that. What you've got to be careful about though off-road obviously is dry grass, because if grass builds up anywhere here between a bracket and the heat shield and something hot, and let's face it, grass doesn't have to get that hot. The auto ignition temperature of dry grass is like 270 degrees C, and catalytic converters work at 400 to 800 degrees C. So the temperature is more than adequate, and you've got airflow as well if you're driving along. So disaster waiting to happen. That just means a human countermeasure needs to be in place. You need to get out frequently when you're driving on dry grass to make sure that it is not building up around the exhaust system, because if it does, that's on you. There's lots of places where that might happen, basically anywhere here where there's a heat shield and low clearance. So come for a walk with me up here and we'll have a look just up here forward, or slightly behind the cross member that supports the rear part of the transmission. There's a bracket on there that might be a bit vulnerable, and obviously all of this area up the top here of both of the muffler and the catalytic converter, there's only a couple of fingers worth of clearance above all of that. There's no obvious entrapment points, but obviously you don't want to discover a mode of failure when there's smoke just pouring out of the vehicle. In rugged off-road situations, this can be an absolute disaster, of course, because if you have a fire, not only do you lose the vehicle, but you lose your water and you lose your first aid and you lose your communications and you lose basically all the support of civilization. So I'd be checking that frequently, but they did a good job with the heat shield and the exhaust, and it all looks pretty pro to me. Nice chunky tow hook up the back too for recovery. It's about 23 millimeters thick and forged, and it's held in place by 3 M12 by 1.75 flange head set screws. So if they're class 10.9, they'd be good for about 4.5 tons of tensile restraint each. So that's quite the rigid attachment. It's only on the left-hand side, this hook. It doesn't have a matching partner over the other side, but I just checked and the 3 holes with their captive threads are present. So you could hypothetically get another one of these out of spare parts and just bolt it up, and then you've got recovery hooks on both sides at the back. The only problem, I guess, is that it is quite close to the side of the tow bar, and a shackle is likely to interfere with that, so you might need to do something about that. Maybe a piece of chain might be easier to deal with there, I'm not sure. Maybe a couple of shackles hanging down like this so you could bend it around the tow bar. Anyway, the main thing is that we know there's an attachment point here that warrants or will support a recovery point this beefy, so that's great at the rear. Not so good up the front though, where the quote-unquote recovery option is a much lighter duty looking shipping tie-down tow hook kind of thing to get the vehicle up on a flatbed or stop it from dancing across the deck of a ship. So recovery anchor point solution up the pointy end is going to be more of a problem if you intend to do any serious off-roading. We need to talk about the drive system because this is significantly different than the Shark 6. The Shark 6 is much more like a Mitsubishi Outlander plug-in hybrid, which is predominantly electrically driven and can really only engage the combustion engine with the powertrain mechanically at speeds over about 70 k's an hour. There's like a dog clutch and it just goes, and you get one speed crankshaft to transaxle. No multi-speed transmission, none of that. This is much more conventional in the context of multi-speed transmission just here coming out the rectum of the engine, and it is connected to the transfer case, which is just slightly forward of amidships on the wheelbase. And then you've got a drive shaft, prop shaft going down to the rear axle and another prop shaft going forward to the front axle. So there's a couple of things there. You've got 180 kilowatts of combustion engine and 120 kilowatts of electric motor, but you only need one electric motor to drive both ends, because the electric motor is located just up in here, inside the 9-speed transmission. And that means the output shaft of the transmission can be any combination of electric or combustion drive, from 100% combustion to 100% electric, or anything in between as the computer determines. But as far as the rest of the drive system is concerned from the transfer case, it's just drive. And that means you don't need an electric motor on the front axle and its counterpart down the rear to achieve all-wheel electric drive, which is kind of interesting. That means you don't need a control system that allows the electric motor down there to talk to the electric motor up here, because it's only got one electric motor, and yet you still get all-wheel drive, which is quite clever. There's a couple of quirks though, like just here, there is a finned sump underneath the transmission. So obviously the designers have incorporated those fins, and they can only have one function, which would be convective cooling. And then they've taken the decision, and God knows why, to paint it. They've painted it black at the same time. In fact, it's the only painted component that I can see on the transmission. The reason I'm amazed with that is that paint is an insulator and its only function is to hurt convective cooling, right? And before any of you say, oh, but it's black, right? And black helps with radiation. That's, where do I start? Physics doesn't work that way would be a good place to start. None of this cooling stuff in a car relies significantly, substantially, or in any real meaningful way on radiation as a heat transfer mechanism. It's all about the convection. So they've gone to the trouble of the fins, but they've painted it. Okay, but as long as the transmission doesn't overheat, that's great. So I find this just very interesting. And obviously, if you're a bit hazy on the transfer case, it's got a few different functions. Its primary function is to take the drive out of the transmission and pump some of it towards the back and more of it towards the front, right? So yay. But it also does a couple of other clever things, like provide low range and a differential lock in the centre here. And that's done by push buttons up the pointy end. So when you press one of those buttons for 4 low or 4 high with the centre diff locked or any of that stuff, what happens is this servo motor rotates this worm drive here, and then the internal mechanism goes off and invokes those different switches, just like selectors would be a better way of thinking of, just like a manual selector would have done in the olden days, only it's interlocked against driver dipshittery. So if you're driving along at 80 and you press 4 low, it won't attempt to do that because obviously something will break if it does. So that's kind of clever, and it also means that you can have a very elegant sort of control architecture in the cabin, and all of the heavy lifting is just done by this technology here. And you can see that the lower edge of the transfer case is very well protected by this, I'm going to say 2.5mm thick fabricated sort of cross member here that supports the transmission, but also prevents anything from biffing this casting that contains the drive gears. And the mechanism here for, actuation is really protected as well. And obviously the different actuations are 4 high with open centre diff so that you can have 4-wheel drive on a high traction surface, so the front and rear prop shafts can turn at different rates when you go around a corner and stop the transmission winding up. Then when you select 4 high for off-road, it will lock the prop shafts into synchronized spinning, so they'll be turning at the same rate, and obviously you should only do that on soft conditions, in soft conditions. And then if you're in really challenging terrain that requires low speed or tremendous torque multiplication, you select 4 low, and that gives you both of those things. So you can go down a really steep hill slowly or climb slowly, and you can also get a lot of traction at the ground thanks to torque multiplication through the gearing. And that all just happens when the servo motor spins and the worm drive actuates, and then a switch inside here tells the computer to tell you that you're good to go. So I find that pretty clever, as well as the integration of the motor inside the transmission which is clever for a few reasons, because it's a bespoke transmission to GWM, obviously, and two, because you can use the transmission fluid to keep the motor cool, which is like a 2-for-1, essentially. Fuel tank's pretty interesting to me too, because it's really quite long. It's like 1.2 metres long. It goes from basically in the middle of the wheelbase to just forward of the differential housing. Not that wide, it's probably about 400 wide and maybe a little bit less than 200 tall. And it's covered in protection plates as well. And they're not just straight protection plates, they've got specific section type shapes bent into them. So somebody had to sit there and think about all of the protection. It's held in place with two straps, and the straps have a very precise shape rolled into them as well before they were bent around to form the strap. And obviously that makes them perform better structurally as well. So this kind of tells me that not that many corners were cut when it comes to engineering the fundamental componentry, which is always good when you're looking at it like that, because when you're looking from the top down at a car, you see the styling, right? When you're looking from the bottom up, you don't see that so much because they presume that no one's ever going to get down there and have a look. So it's often a better window into the engineering than anything else, at least in my view. So someone had to think about all of this stuff and protect the fuel tank, and presumably there's a pretty careful baffling arrangement in here as well, because obviously the inertial loads that the platform experiences are much higher in this longitudinal direction than they are in this transverse direction, and you'd want to prevent a tsunami of fuel from building up and sloshing forwards or backwards, because at times that could lead otherwise to the fuel pump running out of fuel to pump if the tank was pretty empty and an inertial load caused it all to slosh away from the pump pickup. I'm quite confident that's not going to happen because this looks pretty well designed to me. Probably need to talk about the rear suspension setup too, because that's kind of revolutionary for a ute, given that it is a coil-sprung setup. But you can probably see here that there's not all that much travel between the start of bump stop engagement and the actual stop itself just above the axle tube. So it's not set up for particularly long travel, which is not a criticism. I suspect this is set up to be optimised for on-road driving. And obviously, with a leaf-sprung setup, the leaves hold the differential in place, right? They hold it in place in rotation and laterally and lengthwise. And when you stick a coil in there, it can't do that, so you need other links. You've got these trailing links here. You've got a nice big long one here that's about, I'm going to say 650 or 700 long, and its function is to keep the axle in position longitudinally. You've got a shorter angled trailing link set up here, which is about 300 long by the looks of things, and its function is to stop the differential rotating like this under different drive loads, because obviously when you floor it and you put 750 Newton meters down on the ground, the rear axle wants to counter rotate. So whatever rotation the tyres do, there's an equal and opposite rotation of the differential. At least it wants to do that. And without these two links here, it will be free to counter rotate. And of course, when that happens, you would go nowhere until something broke. There's also a panhard rod at the back here, and its function is to keep the differential in place kind of this way, plus anti-roll bar. Now, this is kind of the opposite of the old Land Rover strategy with long suspension travel. So you could keep the tyres engaged in the rough stuff and thereby keep transmitting drive to the ground. There's a different traction strategy with this kind of suspension setup, and that would be the diff lock strategy. Because inevitably in broken terrain, one of these wheels will become airborne, and obviously if this diff was just open, then the wheel that's up in the air would spin and the one with traction would go nowhere, and forward progress would just stall on the grid, which is kind of hateful. So you've got front and rear diff locks with this vehicle, separately engageable, right? So if I was driving in rough terrain, what I would do, if you're not used to doing this sort of stuff, is when it starts to look a bit broken, like the wheels are going to have to articulate a lot, I would preemptively invoke the rear diff lock, because the problem with a front diff lock is it also reduces your steering. Like, it gives you more traction for the same reason. If one wheel becomes airborne, you're still transmitting drive to the one that's on the deck. That's great, but it does reduce your ability to steer. So you can find yourself in off-road situations where you need to carry a little bit of momentum, but you also have to negotiate this broken terrain, and you need to go around a bend at the same time because Murphy's Law. And what happens is you'll be steering like that, and the car goes straight ahead into a freaking tree. So my strong advice would be rear diff lock first, because it won't have as much of an impact on your steering. And then if you still can't get past whatever you need to get past, use the front diff lock, but be aware that your steering control will be substantially reduced. But anyway, I'd suggest that this rear suspension system is great for ride and handling on made roads. And let's not forget, even if you do the Simpson Desert, you're spending most of your time on the highway to get from your capital city to the kickoff point, whichever end you're going to attack it from. You're going to be on the highway. So you need good ride and handling on the highway, irrespective of your hardcore off-roading aspirations. If it didn't have a diff lock, this would be a disaster for off-road driving. But because there is a diff lock front and rear, it's not a disaster. You just have to be aware that one of your wheels is going to come off the deck from time to time, and you need to know what countermeasure to invoke when that happens. And happily, when you've got all of this stuff working for you, it's really good in both situations. Not sure how good it is for really heavy towing, because the heavily laden situation is where coil springs typically let the team down harder than anything else. Leaves tend to be better at that, but worse at everything else. And I'd have to say, this looks like a fairly substantial suspension setup. And once again, when you look at the construction of these links, the welds and things of that nature, and you look at the thought that's gone into the design of the anti-roll bar, and none of this is cheap and nasty. I mean, cheap and nasty sticks out like dog's balls, and this is not that. One more thing, and then I'm going to let you go, dude. This is flat out amazing. You see that? You understand what that is, right? That is a disc brake, and it is up the arse end of this vehicle. Now, to figure out the full horror of this, to figure out exactly why this is such a knee in the nuts to the establishment, I made a list, dude. Drum brakes are still prolific in 4x4 utes. XL and XLS Ranger drum brakes. Triton current model only just released drum brakes. Hilux drum brakes. Navara, BT50 and D-Max drum brakes. Drum brakes are only up the arse end of a ute because they're cheap. There is nothing better about them. Nothing. I'm making a list in my head of all the negatives and positives about braking systems, and the only positive I can think of for drum brakes is they're freaking cheap. And for this reason, more than anything else, this is the quintessential knee in the nuts delivered by this vehicle to the establishment, because 3.5 ton towing, more engine performance than you can poke a stick at. It's got a multi-speed transmission, front and rear diff locks, all of that stuff, high and low range. It'll drive off-road capably as you like. And as we all know, the biggest limitation of off-road driving is either the tyres or the idiot hanging on to the wheel. So guaranteed this vehicle has more ability than either of those things. But the ultimate knee in the nuts to the establishment is Ford, Toyota, Mitsubishi, Nissan, Isuzu and Mazda. Check it out, dude. Not that hard to put disc brakes up the arse end of a 4x4 ute. Hang your frickin' heads in shame because China got there first.